I'd like to welcome everyone to this evening to another lecture from the College of Architecture, Construction and Planning speaker series. Today our guest speaker is Andrew Witt. Andrew's an associate professor of digital practice at Tyler School of Art at Temple University. He's also the co-founder of WITU, Laboratory for Intelligent Environments. He's the co-editor of the recent book, Towards a Robotic Architecture. For his professional practice, he's worked in offices such as Boutique Architects in San Antonio, as well as the Pritzker Prize-winning architect Toyo Ito in Tokyo. Andrew received his undergrad in architecture from UTSA and his master's from MIT. Tonight's lecture is titled From Composites to Robotics, Reimagining the Fields of Architecture and Design. Will everyone please welcome Andrew.
Okay, can you guys hear me? Yeah? Okay, well first, thank you all for having me here. It's great to be back at UTSA. It's like kind of pop in and out every time I'm in town, but it's been a while. So today I'll talk to you guys a bit about where I've come after being at UTSA, which has been extremely influential in how I am as a designer and a researcher. And then also into some of my more recent research on robotics in architecture. And as Armando mentioned, it will be framed through a book that Mahesh Das, also a previous professor here at UTSA. You never know how long you'll work with your professors. Like, this is 15 years now I've been working with Mahesh. So just keep that in mind. We'll be talking, I'll also mention, I'll begin to sort of give you guys an idea of one sort of strain of research within the architectural field. So what I'm saying is not where everything is going. Like, what I'll be talking about is one sort of direction where things are headed and something that I'm really, really interested in working in. So as Armando mentioned, this talk will be called From Robotics to Composites, Reimagining the Fields of Architecture and Design. And one of the reasons that I'm saying like reimagining the fields of architecture and design is because we don't typically think of materials like carbon fiber or robotics in architecture. So for me, to begin to think about using these new things in architecture means kind of forgetting, or not forgetting, but putting behind all of the preconceptions that you might have about design to think about buildings and how buildings go together in a different way. But before I get into this, I'll give you a quick sort of background from where I come from. As Armando mentioned, I started right here at UTSA in 2001. I graduated in 2006, worked with Jim Poteet at Poteet Architects following that, and then went to MIT for graduate school. After that, I've lived in Japan, in Indiana, Philadelphia. I've worked and presented my research in a lot of places, so I travel quite a bit. But that's just part of the fun. Like in architecture, you can kind of go wherever, and it's not really based on language, so you don't have the sort of boundaries you have in other disciplines. So for me, there's four things that are really important in how I think about design. One is form, as most of you are probably interested in how buildings look. The other is material, and new materials and how they can redefine form. The third one is computation, so using computation as a method of integrating new materials and creating new forms. And the fourth thing is machines. And so this is not just robots, but like any type of machine. So even from dumb machines like a drill press to anything, and how all of these things go together to create a new type of craft. So whether I'm doing a drawing or making something, craft is always the thing that like I'm most interested in sort of making. Sorry, this is really slow, but just to kind of bring you back to where I started, this is a project that I did here at UTSA second year. This was basically, like second year I think was where everything sort of started changing for me. I told Mark, like, I can't draw. And so I had to sort of come up with a different way of working. And so for me, it was always through physical models or digital modeling. And in 2001, digital modeling was different. And people had much different opinions on it. But I kind of ran with that and looked at these technologies not as something to replace everything, but as an addition to everything else. And so when I can draw, I try to, but if not, I work through the computer. Right before I left, another project that was really sort of integral to where I've gone was the entry canopies that we did as a team in Mahesh Das's last studio, or my last studio with Mahesh Das, and many of other students in the class, along with some faculty who are still here, like David Mathieu, Curtis Fish. I believe Stephen was in this class, but I don't remember. That was a long time ago now. Were you in there, Stephen? Yeah, sorry. So Stephen.
One entry canopy.
Yeah, I don't remember anymore everyone who was in there. But the reason this project really got to me is because thinking about how to use technologies in new ways, and like when it comes, like me, I'm super anal retentive when it comes to details and understanding how everything goes together. And so when we began planning this, thinking about how we could use these new materials, also how we could begin to raise the money for these projects. So we didn't have money. We raised the money as a class. So we went out, we got donations from people. People let us use their shops. We did whatever it took to basically get this done. And that's kind of stuck with me for a long time. Because I've never had the money just thrown at me. It's always like, how can we do everything without having to pay for it? And we've been very successful, or I've been very successful. My classes have been really successful in this. So following this, I went to MIT, and this was another project that we had gotten completely funded through through grants, through the government of New Bedford. It was just a floating, tessellating boat dock, but again, just pushing back and forth between digital and physical. And again, I am very interested in how every single piece goes together. This was 2006, and this was all water jet cut. Aluminum with hand-cut wood on top, so it was a mix. After this, I kind of went into practice for a while, and so I'm constantly floating between making buildings and then rethinking how buildings could be made. And so going to Japan and having access to all these tools when I was in the United States and in school, I was like, yeah, I'm going to do all that right now in these projects. And so I designed everything to basically be fabricated through whatever tools I had here. So water jet cutters, CNC machines, robots. And I very quickly found out that in China, they don't use that. So it was like, okay, we designed all these things. Now, how do we make it so that it could be handmade? And so one of the really important things that I found from this is that you can plan for everything to be done one way, but it has to be able to be done in many, many different ways. And so the kind of cool thing with this project was that I designed it one way, and then we basically reversed engineered it so it could all be done by hand and very quickly and efficiently assembled together. And so the facade of this bridge that's crossing, the intricate little patterns that are on that, basically they were all hand assembled, but we came up with a logic that allowed everything to be bolted in place, and basically the entire facade was just held together in tension. So it's a super lightweight facade that was able to be put up very quickly. And then I always like to show this project just because it was a jail that got turned into a kindergarten. That's like a school project right there. And so the government just gave it to our client because they wanted a good school. And again, like money was very low, but color, thinking about how, like just, this is more of like the building sort of, me working with buildings. But after this, like after like UTSA, MIT, and practicing for several years in the States and in Japan and China, I kind of decided that there were three things that basically direct me in all of my work, and I decided that I wasn't going to make buildings at the moment. Like I was going to go back and I was going to try to rethink what buildings are and how we make them. And so my first sort of thing is that like I don't believe in like givens. And so people tell you what they think a building should look like, but I don't buy that. And so I think that we all have preconceptions of what we think the built environment is, and I think all of those are free to be broken. The second thing is that like I don't believe in hierarchies and collaboration, so all of my classes, my students are equals to me, and it's their prerogative to break the rules that I've set for them. And another thing within that is that I work with everyone. And if you go to my school, you'll realize that I'm not just in architecture. I'm always in sculpture, I'm in ceramics, I'm in glass, I'm in metals, I'm in whoever has a different set of skills than me. I'm working with them because we don't know everything, and we shouldn't try to know everything. Like if we're working with people who are different, you get new types of projects. And then from being in Japan and China for so long, my sort of last thing is that design itself is a language that transcends all borders. And so if you're working in a country where you don't speak, how do you present your work without having to say a single word? And so if you have to talk for half an hour to explain your project, you're going to be in trouble, right? Like nobody's going to understand, it's too complex. So everything needs to be really, really easy to understand. So from here, I got back into academia, and I went to the middle of nowhere. So I went from Tokyo, the biggest city in the world, to Muncie, Indiana, which is population corn. So like it was just corn and a robot that I got and some people. But the thing that's cool about that is that students have nothing else to do besides work. So not that we're putting them like saying that you only have to work, but they're like it was like you have nothing else. Like why not make something cool? So when I got back, I worked with one of my friends, Gernot Rieter, who's the director of NJIT now, and 6 graduate students, I think, and we basically developed this pavilion in 4 weeks, over a 4-week summer studio. We just told the student the only requirement they had is by the end of the semester, they had to build a full-scale something. But they had to question whatever that something, like whatever the preconceptions of that something were, and build it new. And so they decided to go for tensegrity for some reason. I don't know why. But they said, well, tensegrity structures they're typically all done by hand modeling because it's really hard to figure out how to calculate all these points in space. We're going to come up with a computational system to basically produce these tensegrity structures. And in 4 weeks, after nearly not making it, they put everything together, and it was really pretty great. And then the other end of the spectrum of my research is writing. And so Mark and I had a long conversation about this today. Writing is very important. Like I just finished the book with Mahesh, Towards a Robotic Architecture, but then recently in Mexico City, we just presented the other 2 on the right, which are the conference proceedings for the Acadia conference, which me and 2 of my friends just finished over the summer. So I'm always working between making, like testing, and then writing, because like you need other people to understand what you're trying to do and tell you whether they think it's like you need feedback basically. So all of this kind of gets me to one project that I'm working on, and that one project basically has like 1,000 small projects to help me try to figure out how to make this work. And so that project is called the One Day House, and rather than trying to just create a new form for like a dwelling, for me the goal is rethinking exactly what is a building, like what does it do, what should it do, and how what would be the ideal situation. So form has nothing to do with anything at the beginning. Some things that I'm trying to think about are like how can buildings become income generators versus just things that suck money from you? How can they produce resources rather than only taking resources? How can they adapt to the environment and to the people who are using them? How can they be aware of themselves and their environments? And not that it means it's watching you all the time, right? But it means like, how can they begin to, like, if the weather begins to change and you have the sun beating down, how can they begin to change to, like, basically block that or something like, how can they be more connected? And then while all this is happening, how can they still be extremely personalized? So to do that, like this is just a form, it doesn't matter, but it's beginning to talk about a new language where things are no longer defined by rigid materials. And so all the materials I work with are very lightweight, like carbon fiber. The chair of our department and I, Rashida, and I'll show you a project in a minute that we're working on, works with these reinforced lightweight materials that have embedded other materials to mediate temperature. But so how can we begin to rethink the systems that make up a traditional structure? And then again, how can they begin to adapt based on temperature and other things? But in order to do that, what I really enjoy doing is making the tools to make these things possible. And so it's not just about designing the artifact. One thing that you guys have the power to do is design the tools to make the sort of artifacts. And so this was a project that myself and 2 of my graduate students in Muncie worked on called RoboWinder. And it was basically just something that we added to the end of a robot to look at how you can wind carbon fiber modules for a building system. And this was like 5 years ago. So Other schools have taken it way further, like the other schools were first also, but we were just trying to figure this out ourselves, and we were trying to see which direction we wanted to go to. But again, we had no money, and so we made the entire thing from scrap. And it basically got us some sort of, it gave us feedback on what worked and what didn't work. From there, I went to Philadelphia, where I'm at now, and I worked on a project called Roly Poly with one of my friends, Simon Kim, at the University of Pennsylvania. And for this, what we were interested in is just like, can we make a structure that's structural in any orientation, that can be inhabited in any orientation, but then also that gives you new types of sort of textures and visual and tactile appearances. And so we kind of, we have this form. This was the project Roly Poly. It's just it's a little sort of pavilion for a single person. But the thing is, it can be oriented in different directions. Again, like I work with tools like robots, but we still work with like hand welding. So this is my friend Tim, who's a sculpture major. He always helps me with welding. Coming up with our own details. So like how do you, like if you're not working with drywall or studs where you have to nail things together, like how do you get fibers to stay in place? Like what does a fiber do when you're working with it? And how can it become a building material? And through many tests and then really big kilns like the thing in the back, we basically created this sort of environment where this is a monocoque structure, so it's a single shell, but the sort of textures and the views that you get through this are so much different than anything that you would have in a typical building, because you can control every fiber of the structure, which for me is extremely interesting because we're so used to having something that's either opaque or transparent. But if you're working in this way, you can have gradients that can basically do anything you want them to do. They can do anything you need them to do based on environment or structure or any of the constraints we typically have in architecture. But they also give you sort of unexpected results. So this was, we have a red wall in our gallery at Tyler. And basically, I didn't realize it would happen, but it absorbs the color from around. So depending on where you are, the artifact looks different in all different lighting conditions, which is really nice. This is kind of a fun project that I did with the chair of our department, Rashida Ng. She had gotten a grant to make cloud-making kites in Costa Rica, not as a means of making clouds to solve problems, but more of as a means of showing how the cloud forest has risen over the past 30 years and what it's doing to the cloud forest below it. So as the cloud forest raises, it's basically killing off the ecosystem below it. And so these kites were basically going to be flown at the original level of the cloud forest, and you would have like a stream of cloud behind it. That's the goal. We're still in the process of making this work. But for this, what we did is we started working with fluid dynamics. So we were working with somebody in engineering who was basically telling us or showing us how forms work and how air moves through. I brought my knowledge and my desire to use carbon fiber to begin to create very thin structures. From the beginning with these very wasteful sort of prototypes with the cardboard to the end where there's no waste in the production of the structure. So here's one of the early prototypes. Again, getting to play around with details to figure out how strength works in the fibers. So we basically brought 3 kites to Costa Rica. And then we looked at how you can wind the kites to program the structure. So one of the really important things is we can't send these sort of gigantic things uncompressed to Costa Rica. So they had to be big, but then also collapse down to be in a very small box. And so we could basically program how the material works by how it's wound, which was really fun to play with. And so the ends of this, so we brought 3 quarter-scale prototypes to Costa Rica. Basically, this whole thing could collapse down. You could nest 3 of them together, and they can fit in an 18-inch diameter box that's like 4 feet long. And then you bring it on site, you cut open the box, and it basically just like springs back into its original form. So here you can see it kind of in its, so this is quarter scale. The real versions that we're going to work on are the size of a car. So they're much bigger. But here you can see it sort of, we just zip tied it shut. And then inside of that, there were sensors embedded because we need to know how the environment is changing from the front of the kite to the end of the kite. And then, this is not me, as Rick Lewis was confused about. I have never had a beard. I lack that ability to grow beards. This is Justin looking very happy. I did not go to Costa Rica, but we sent 2 students in my place with Rashida so they could actually go and test these things. We're going through data right now. We weren't able to create the clouds, but we were able to drop the temperature significantly. One thing that I didn't mention is Rashida's a materials researcher, and the skin of this kite, which is actually based off of how we did the sails here at UTSA, this skin is impregnated with something called a phase change material. And depending on how heat touches it or compression happens, it cools, it basically melts and sucks the energy out of the air to cool it down. And so one reason the kite is this shape is it's sucking in a lot of air, and then it's being compressed, and then it melts the material to suck the energy out of the air to cool it down more to basically attempt to create kites. And so we have to decipher, basically go through all the information, see how we need to edit this to get the temperature to drop a bit more, and then we can go back hopefully to Costa Rica and test them again. So next time I'll go, I hope. But super fun project. Somebody in Japan wrote a haiku on how it didn't work. So that was also fun after the lecture. One of my more recent projects that I'm working on, there's 2 projects that I'm working on right now. Unfortunately, I can only talk about one. Hopefully in a year or so, I'll be able to talk about the most recent one. But this one is just a sort of fun project where I was working again with Simon Kim and looking at creating, this project is called Dinner for 6. And so the goal was to create an enclosure for 6 that could be reconfigurable so that each one of these pieces is a character and they could be used in different ways and reorganized in different ways. And so this is will be a carbon fiber structure. Another goal with this one is that I'm trying to use I'll completely eliminate waste in the construction process. So I'm using a fiber or a scaffolding made of string. So basically, you hold fibers in place with string, and then once they're tensioned and then fired, you just remove the string, and then you can reuse the string for the next thing. One thing I didn't mention about carbon fiber and why it's not really, carbon fiber and fiberglass aren't used very much in architecture is the amount of waste that goes into the production of molds. And so, like in airplanes, when they make a plane out of carbon fiber, they basically have like a giant mold of the plane, and they just like wind it around the mold. But those are, since the shape of the airplane, you can just pull the mold out, it's reusable, but you can only ever have one shape. Now, like with the Confluence Park, they had to make molds for that, but those molds are only good one time. And they had to make, in like the negative, so they had to make a big foam cutout of all of those beautiful arches, and then they had to make maybe another sort of like fiberglass, or I'm not sure what the other material was, but they had to make another mold on top of that mold, so then they could put the carbon or the concrete on top of that. And so there's a lot of waste in the process, and with carbon fiber and fiberglass, it's the same thing. You have to make these molds, and so your options are: one, you make one mold and you just repeat over and over again, or you have to make individual molds for everything. And each mold that you make is basically garbage. And that garbage is usually foam, and foam does not break down very well, right? So you're just like, it's a very, very bad process. And so there's problems with carbon fiber at the moment in terms of resin systems. So something later I'll look into is resin systems that can break down so that the carbon fiber can be reused. But the first goal is to even see if it's worth being a building material. So in this project, we're trying to completely erase the waste in the carbon fiber production. This is like a very small, it's like a half-scale prototype of the system that will be wound upon. And so this is basically just a carbon fiber scaffolding that carbon fiber will be laid on top of to make the structure more rigid. And so there was very little, almost no waste in the production of that. But then again, you begin to get these new types of effects. So that's where I'm coming from in terms of making. And so there's like the making part of me, and then there's this part of me that's come recently in the past like 5 years, which is I have to do a lot of writing. When I write, just like when I collaborate, like I like to pull in other people into the projects because, again, like I don't know everything, I don't want to know everything. I'd rather just work with people who know things that we can basically come up with new ideas. And so Mahesh and I working together, we made this book called Towards a Robotic Architecture. It's always, people always think the name is, even when they do nothing, robots are evocative, but we wanted to try something different. So whether it's successful or not, that's another question. But we made this book. It's very colorful, so if you don't like color, you might not want to look at it. If you stare at it too long, you might go blind. But it is very colorful. But inside all of this color, we have a lot of very interesting people. And all of these people are doing something different. And I'll kind of talk about several sort of areas that I think we need to think about how tools are going to begin to change how we make. And again, like this is not something where it's like this is not where everything is going, right? This is one sort of strain of research where people are taking this. There's many different sort of pathways you could take, but you guys should all know what's happening. And this is what I tell everyone, especially my students, you should have a stance on this because like you could love it or you could hate it, but if you don't say anything, it's going to happen and you're going to kind of just like CAD, right? 30 years ago, it just happened. So you should be aware of it. And one of the things that's that we've already seen happen in our lives, whether we're aware of it or not, is there's a shift towards robotics and AI. Like this is happening everywhere. There's Esmo, of course, so like a literal robot. There's, I don't know why this is happening, there's drones, like bad things. But then there's things like this, Google's DeepMind, where basically Google's neural networks are trying to figure out how images are made. And so like you put a picture in and then it tries to put lots of other images together to figure out what it is that you're putting in there. And you get these sort of like crazy paintings. But for me, one of the problems is like we have all this stuff outside of architecture, but in the end, like in reality, our phones have more intelligence than our buildings, right? And our phones cost several $100s, and our house is going to cost you 30 years of your life, right? And so we're willing to throw away these things that are super smart, but we're not willing to basically make our buildings more smart. And so the question is, how do we make buildings more smart? How smart do we want them? And what does that get us in return? So in architecture, like over the past 25 years, we've seen digital fabrication allow or afford architects new forms. But the problem with those forms is that they're still equally as dumb as as everything before, right? They're just like more round or they're put together in a different way. So we like to say that. But so Frank Gehry, it's a very nice form, but at the same time, it's basically just another building, right? The only thing that's new about this is that he used CATIA or whatever software to allow for a panelization of the facade to create something that's different. It could be very efficient, but it's still static. Or to more recent projects such as Mark Fornez, there's at least one or two of these in San Antonio of his little pavilions. I would suggest finding them and just looking at them, and you can hate them or love them, but you should see like there's something very evocative about how these things are made. But in the end, they're basically just the same thing but done in a different way. So the difference between digital fabrication and robotic fabrication, or even augmented fabrication, which is beginning to happen more now, is that you're no longer just making a file, giving it to someone, and then voila, something hopefully happens. Basically what's happening now is that making is happening in real time with you and whatever the tool is. And so it's not about like automation. Everything that we're talking about is about collaboration. We typically collaborate with people, but now we have to learn to collaborate with machines, because this is not what we want, right? Like, this is like, yes, they're making cars, but at the same time, like, who wants their buildings made like this? You want it to be as sterile as the car. And if something happens here, like everything sort of goes wrong, right? So like if something breaks down, something, it just doesn't work. This is a project by the ETH Zurich. It's the largest robotically fabricated roof in the world. It's for their new architecture school. It's pretty amazing, but again, it's still just like digital fabrication-esque. More recently, this is a project that was done by some graduate students at the ICD, the University of Stuttgart's Institute for Computational Design. Now, why this is interesting is this is a roof structure, and it's a carbon. These are carbon fiber modules, and basically, it's tracking people around this sort of pole, and you can tell it via phone whether you want shade, don't want shade, you want the thing to follow the sun or not follow the sun, and basically it reorganizes all of these panels in real time, tracking the sun and based on what you're telling it and feedback in your cell phone. And so the architecture is no longer static, which is quite interesting, and it becomes a collaborative effort between the designer to design all of these different elements, and then the people who are actually like the players in this, the people in the environment occupying the space. And so as I mentioned, we're talking about collaboration, not automation. So here, Rodney Brooks high-fiving the robot. Two, here, the ETH Zurich, where basically you can see here that this guy is drawing with chalk on the ground, and in real time, it's 3D scanning it, and it's building a brick wall along that chalk line on the ground. And so there's many different things you could do with this. This is just one of the examples that they were working on. Another example is to save craft. So this is a project. I'm going to say his name really badly. Giulio. I'm not even going to say his last name, so it'll be really bad. But basically what he's doing with InnoChain is, and he's also working with big architects. So you guys probably know Big. A lot like Zaha Hadid's also working with robotics as well. A lot, I think Norman Foster also. But so basically what he's doing here is there's actually a craftsman, like a woodworking craftsman who works with the tool. It 3D scans that tool in space. And then this robot here has force feedback. And so it's looking at the force and how everything goes. And rather than just trying to reproduce the same results, what it's doing is when you change the material, it's trying to figure out how, when you change the material, it changes the effect of the like on the wood. And then basically, if you wanted to try to replicate the same thing, it'll learn to do that. And so, in sort of craft-based disciplines, like where it's extremely intensive and people aren't willing to, we see it kind of dying out, like stoneworking or things like that. People are actually beginning to encapsulate that knowledge into these tools so that it could be continued to be used, but also be retaught to people later on. So you could see how this thing is working and actually begin to work the material yourself. And so for me, another question is how do these things begin to fit into architecture? I don't know if you guys know Greg Lynn, but he was really big back in the 90s. And he started a lot of the research in robotics, in digital fabrication, and also digital modeling, a long time ago. He's now working for Piaggio Fast Forward. He's their design person, but this is a project they're working on now. It's like a little robotic suitcase that follows you around and can navigate traffic. So it's a little weird, but we see these applications happening like this. Or we see the applications happening in space, and that happens like this for obvious reasons. We can't just send people to Mars and expect them to live. But in architecture, this is what we see in terms of robots. This is a robotic library. I think it's at the University of North Carolina. We're getting one of these at Temple right now in our Shinoheda library. But this is it's pretty boring. It's not really doing anything to the architecture. It's hidden in the basement. So the question is how do we begin how does this begin manifesting itself in architecture? And I'm sorry, I'm not sure why that's happening. What we see in the sort of other direction is the Nest, which is if you're just taking a dumb system and trying to add something a little bit smart to it, but it's not. You're just putting a Band-Aid on a big gushing wound. And these things, they're obviously going to transform planets like Mars. So, such as in Peter Novikos' NASA-winning project here. So this was a robotically printed building on Mars through harvesting water and then they basically harvest water from the regolith and then 3D print it into a structure like this. So it obviously makes sense in other places, but it will also make sense in like here on Earth with us. And so Mahesh and I basically started to think about a framework. So like one, like how do humans, robots, and architecture interact? Because this is really important. Like you just don't put these things together in a room and expect them to work. The other thing that's really important to understand is like what are the role of these tools in architecture? So like not everything should be a robot. Like you shouldn't just use things because you think they're cool or you think they should fit in. Like you should use a tool for a specific reason to further, hopefully, mankind, right? And so we want to understand why they're in there. Like, do they design? Do they fabricate? Do they build on site? And then the last thing is basically what does it mean when buildings become robotic? Like we don't know if this is ever going to happen, but there could be components of a building that's robotic. There could be systems such as HVAC. There could be structures that allow it to move to for like earthquakes, or spaces themselves could become robotic. And so the first thing that we begin to look at is production, and so how these tools could be used for making in architecture. The cool thing about like industrial robots is that basically you can put anything on, from a bandsaw to a hot wire cutter, to make basically like a very, very tall foam structure, as Brandon Clifford and Wes McGee did in this project nearly a decade ago, to even thinking about using new materials. So this is the AA Design Make, where they basically just went into a forest and picked trees that have like a Y in them, trees that wouldn't typically be used. They 3D scanned all of the trees, and then they basically made a design model that only picked the trees that were best fit for that model. And then they only cut those trees down and they used all the parts and they used traditional joint work to make it happen. So instead of deforesting an entire area, they scanned the entire area, found the best fit trees, and then used those trees to basically make the structure. And so here you can see the details of that. Super interesting project. Or like Paul Nicholas in his robotic sheet forming, where he's trying to use recycled aluminum. The reason recycled aluminum is really difficult is because it's not homogeneous, or it's not a stable. Like you don't know how the material is going to react. And so what he did is basically they're basically rolling this like you would roll like a gas tank on a motorcycle, or like how you used to make a car. And so there's a robot on each side that's forming the material. So you give it a design, and basically what it's trying to do is as it's working the material, it's constantly scanning it to see if the material is working as it should be working. And if it's not working correctly, it readjusts its model without you having to readjust the model to try to fit what you want. And so right now, if we're just like CNC milling something, or basically you would have to redo it. If you're doing it by hand, you have an eye, right? You can see it, you can be like, okay, it needs to be shifted this way. But basically he's bringing some of that intelligence into these digital tools that we use, so that like hand making and digital making get closer together, and so that you can begin to interchange how this can work. Other projects such as MX3D and Joris Larman, who created the sort of 3D printing of steel in space. What they're able to do then is create structures like this. This is their very early project, the Dragon Bench, where you can make these crazy forms in space without having to have any waste. To their most recent project that they just finished, they were working on this when we did the chapter in the book, but they just finished this now. This is the first 3D printed bridge. It was printed with the robot, with the welding end effector that was on there, and basically it was just they just continuously printed it. They wanted to print it on site, but the government did not let that happen. So, but their goal was to have a robot on both sides, and it would basically print to the center. But they just finished this, and I think they're installing it pretty soon. So it's pretty awesome. To Shop Architects, they worked with Branch Technologies in Chattanooga, Tennessee, to create the Design Miami Pavilion, this is all plastic reinforced or carbon fiber reinforced plastic. So it's a huge structure. And it would be very difficult to do that by hand. Two things like carbon fiber. So this is the University of Stuttgart's ICD research pavilion, where you can see that there's new sort of textures and visual aesthetics to this sort of structure. So like beyond the tools themselves, because again, just like softwares, you don't want to, like, you shouldn't be fetishizing the tool or the software. None of you guys have heard of Form Z, right? No. Yeah, except for the people who were here with me. So, like, that software is dead. And so the software that I learned here no longer, well, it exists. It's just very sad. So, like, nobody uses it anymore. So Rhino, you guys are using that now. Who's to say that in 10 years it still exists? It's not the software that's important, it's the skills that you're learning and how you can translate those to other things. And so with that, instead of focusing on the tools, we're looking at tectonics. Like how are these new tools and materials going to reshape the tectonic sort of field of buildings? And so this is another carbon fiber and fiberglass detail. This is, the Institute for Computational Design at the University of Stuttgart. This was basically an ETFE balloon that they laid a carbon fiber structure on inside with the robot. And so there's a lot of interesting things that happen, but this is a new type of form that you typically wouldn't have through using traditional materials. This is an earlier pavilion that they did in 2014. So these are all done by like their PhD researchers or their new master's students. And so like this one here, unlike the last one, which was built as a giant shell, this one is built of these individual modules. I believe they're going to build a giant bandstand in New York City. Akim Menges has gotten, I think, a commission to do that in the next few years, which is going to be kind of crazy. But again, this is a new type of aesthetic that you get. And then how it's put together also becomes a new sort of game of how do you work with these materials that you never worked before. And so this is them working with two robots. You have to put a fiberglass, they put a fiberglass layer down first, and then they put the carbon fiber on top of that. Paul Nicholas, this is the full pavilion that I just showed a minute ago. So you can see the scale of these things. We're moving from, just like with digital fabrication and all of these tools, you start small and they begin getting bigger and bigger and bigger. This was Paul Nicholas's, their recent bridge that they had done, A Bridge Too Far. Same sort of logic, but just they refined it from the previous project. And here you can see the machine basically working the material. There's a lot more that goes into this, like computationally, but I'm not going to go into all that today. I just want to kind of give you guys an overview of some of the things I think are interesting that we highlighted in the book. To Roland Schnooks, basically at RMIT, who in Milburn, who basically had to change the building codes in Australia to allow him to 3D print parts of buildings that are going into it. So this was one of his prints that he was working on that became an interior of a project that was in process while we were writing the book, but he's finished this now along with several other projects. He was using it as a sacrificial formation, or as a sacrificial formwork. So it was like a plastic with, I believe, carbon fiber reinforced cement inside it. To moving to multi-materials, which is really interesting that you could do with robotics, to even really complex forms such as Manuel Jimenez Garcia and Gilles Retzin's series of chairs that they are doing with, and their students are doing. And so the one thing that's really interesting with this is that you can really begin to be specific with how materials where strength and flexibility begins to happen. So you can see that there's areas that are like really dense, and then areas that just begin to fall away. Moving away from sort of tectonics becomes sort of architectures that are slowly becoming robotic, or thinking of new ways of making architectures that are robotic. And so at the ETH Zurich, the last picture was from the ETH as well. What you're seeing here is, they did a lot of bricklaying robots a long time ago. This is one where basically they're 3D scanning the entire environment. You can see the bricks that are already down, and then the bricks that are in the model that are to be placed. Something that's interesting about this is that you can change the design as you're going along, and so the bricks that are down, but you could manipulate things above that to have them change. Like there's a big potential for things like that in there. This is a more recent project that they just finished called Meshmold in their Nest project in Zurich. And so basically this is a robotically bent steel formwork, which they then put they basically put the concrete on top of this, and they use a very thick concrete which allows them to not have to use any wasted, there's no formwork that goes around this. And so they make a very dense reinforcement, and then they just basically pack all the concrete in there, and then in the end you have the finished wall with no wasted plywood or materials. And the thing is, it could be basically any shape. This isn't a crazy building where they're just testing all of these things that they're making right now. Back to Joris Larman. This is an interesting project he did where basically they were questioning how to make flat pack furniture. So we all know IKEA, you get it, it's all blocky, falls apart, kind of sucks. So what he was thinking is how can you have flat pack but bring the making to basically happen anywhere? And so basically what they did is they created a system in which curved folding could happen, and then basically anybody who had you could have these sort of things placed anywhere. Like you could have a small maker in some place who then could make these robotically fabricated pieces of furniture. And the thing that was really interesting is from a flat piece of material, you could basically score it with the robot and then fold it into shape, and you no longer have the sort of IKEA forms, but you started with something very flat where the material could come from anywhere, and you wind up with something extremely volumetric in the end. This was the butterfly screen that they did shortly after, or several years after that. Two more robotic structures. This is a project by Wes McGee at the University of Michigan. There's a lot that goes into this, but basically it's a space that could transform its shape based on how you want it to be. Just for me and anybody else who might be really nerdy, he designs all of the sort of components that goes into it, which is really fun and nerdy. People who are looking at means of using big cable robots to build on site. So this is Jose Pedro Sosa and his researchers are looking at large-scale construction robots that could work on site. The thing that's really difficult with that is how do you navigate in uncertain terrain? Birds, animals, people, rain, all of that stuff becomes really interesting. Finally to Behnaz Ferrari, who basically, she made this wall that can change based on gestures, so you can control the wall based on how it basically sees you and then reacts. To one of her more recent garments, would basically it reacts to how you're looking at it, and so it can tell your gender, and then it can tell. I think it can see three. It can differentiate three sort of smiling, sad, or something. But then it can also track your eyes. So if your eyes start to wander, the garment starts to change. So even controlling your personal space becomes really interesting. The last thing I'll sort of leave you off on before you guys are more than welcome to ask any questions you might have, or the future. Where could this stuff begin going? I start off with Philip Beasley and his crazy sort of environments, and to Neri Oxman at MIT, who's basically rethinking materials through. She uses this is made of cheetah sand, so one of the most abundantly available natural polymers, and she basically robotically prints these pieces, and they're able to fold into shape after. And so the thing about this material is that it can break down and it's not a polluting material. So I'm sure I don't know everything about it, but she's basically reinventing how materials work. You can see it in a flat state over there, and you can see it in its sort of curled state. And so this has been referred to as 4D printing. Skylar Tibbetts at MIT is also one of the people who basically started that. Two things like Martina Decker, who's looking at soft robots. And one thing that's really important to realize is that you'll start seeing a lot more videos about industrial robots, but those are not the only thing. So Martina is very interested in soft robots because traditional robots are very heavy and they're made of steel and they will hurt you. But the thing is that if you're in a hospital and you're impaired, how can you begin to have robots interact with people that are safe? This is a project she did called Soft Frit. And so it basically follows the sun. When the sun's around it, these frits expand to block the sun. And when they block the sun, they basically suck up the energy, and then they glow at night. And so they're blocking the sun during the day, and then when they release that energy at night. And then this is you can program these things to be any types of form. She's made one that talks. But the thing is, in hospitals, like like if you have a robot that's there, and like you can't have people bumping into these things. And so, what does soft interfaces on robots begin to look like? And that's one thing she's looking at. Skylar Tibbetts, he's looking at 3D printing in new types of materials. So this is a completely wasteless printing process in which the material you're printing is actually the same density as this gel, and so you basically print in space, and you can intersect with it as well. And also depending on the speed you're moving, you can change the depth or the thickness of each of these members. And he worked with Steelcase, and they made a series of furniture pieces, which are pretty great. What I mentioned just a minute ago, 4D printing, where you print something flat, and based on multi-materials, it can turn into something different. And so this is more beginning to look not at robots as like electrical mechanical machines, but more as like intelligent materials that can do multiple things. And so based on an input, whether it's heat or humidity or tension, it becomes something that it wasn't a minute ago. These are some of Philip Beasley's things. They're these kind of crazy, it's like an environment that you can go into, and they try to learn. Like, so you interact with them and they try to learn, and the thing that they're trying to do is not be bored. And so if they learn how to do something, they don't want to do it anymore, and they'll try something different. So so they're working on that now, but it's really interesting. So it's a really immersive sort of environment. But beyond just the sort of gallery aesthetic, what he's trying to accomplish is pretty interesting as well. But also, again, the detail he goes into in making all these things is really quite elegant. Mike Silver's brick carrying robot. So this is actually funded by, like, I believe, a brick masons guild. And the reason that they're interested in this is because you usually have a bunch of people carrying around heavy bricks, but those are the people who wind up getting hurt. Because they're carrying these bricks around, they have to go up ladders, it's dangerous. And so Mike is basically working on these robots that can carry bricks to the master brick masons and basically help them, like, so that they don't have to carry all of the heavy stuff. And the people who are doing the craft, that craft remains. And then the job, like the guy that's carrying the brick, it's sorry to say, but they wind up getting you get the robot. But the other thing that Mike's a really funny guy, but one thing he was like, at the end of the day, could bring you 6 beers instead of 6 bricks. But Mike also brings up a very important point in his chapter, and it's like, how intelligent do you want things to be? At some point, if they get too intelligent, your house is going to tell you it doesn't want you in there because you're violating its privacy, right? And so that's a reason why it's very important to understand where things are going so that you can basically help shape them in the direction that we want, right? Because if we leave these open to the people who only want money, they're going to do the things that we don't want them to do. And so here you can see one of his older versions in action. To architects designers such as you guys, moving into other industries, I think that's really important as well. Kendra Bain was an architect who went to this place called Bot and Dolly, which got bought by Google. But basically what they were doing is creating these sort of immersive environments, and they were the ones that actually figured out how to make the movie Gravity work. So the question was like, how do you make these people seem like they're floating in space the whole time? And basically they found a way to make everything in this is robotic. The screen, the background is robotic. They're moving on robots. Everything is basically one giant orchestration: cameras, lights, all of this stuff. And so it's interesting, not that we want all of that stuff happening in our buildings, but there's things that can be learned from this. And also, you guys should know is that not everyone goes down one path, right? Like, I was talking to Diane Hayes today, and she was talking about how everyone kind of goes to these different things that are not architecture, which is pretty freaking awesome. So just remember that what you're doing now could lead you somewhere else later on. And last, I'll leave you with the Mars project, again by Peter. It's a really interesting project. They actually built the 3D printer for this, so they can print, basically they can print out of water, like super cooled water. And if this was to happen, it would be really interesting. There would be very little waste. They basically just bring an ETFE balloon up there, they inflate it, they print inside the balloon. And I believe the balloon helps with blocking the UV from breaking down the ice. So whether it's on Earth or Mars or wherever, like these things are beginning to happen, so keep that in mind. If you guys have any questions, you're more than welcome to contact me. You can shoot me an email. I have more stuff on my website. I haven't really updated that in like 2 years. I've been really busy. And I'm also, like, most of my research is available. Like, you can just download it if you're interested also. So everything is like online. So you're more than welcome to take a look or ask me whatever. So thank you for your attention. I know that's a lot of information. Thanks, guys. Does anyone have questions, or is everyone just completely confused?
Yeah, does anybody have any questions for Andrew?
Okay, so you remember when you were talking about those little dots that you mentioned that absorb the sunlight?
Yeah. The phase change material.
Yes.
Or, yeah.
And you said that you could program them. Like, how exactly can you program them? Can some emit more light at night than others?
Oh, so Martina Decker's project, the Soft Grid. So like you can, like, so she has like different materials embedded in there, and basically you can change the consistency of the materials so that they do different things. And so if you wanted certain areas to inflate more, you could base it, or also I believe there's a pump in there, so like you could program the pump. So I'm pretty sure there was an override so that you could basically block it off if you wanted it to be blocked off, or open it if you wanted to be open. But there is sort of the mechanical way you could do it, or you could change the consistency of the materials, which would allow you to do things in different ways. So for us, with the kites, where we're going next is, like, at the beginning we just had the same amount of phase change material all over everything, but now we need to get much more specific, and we can even pick materials that have different melting points. So as the air moves through the kite, it's getting colder, colder, colder. And so we need to have something that melts at a colder and colder and colder temperature. Otherwise, by the time it gets to the middle, it's already spent and you can't go any lower. And so materials can allow you to change, like that's one way, would be to just have smarter materials that allow you to do what you want.
Cool, thank you.
Yeah, no, of course.
Okay, thank you, first of all. I wanted to ask, being that all of these things, or a lot of these things are like trial and error for all of you pioneers that are working on this right now, how do you think it is that we're going to be able to pass this very valuable knowledge down from all of y'all that are working on these things to people that aren't as familiar with these technologies? Because all of this information and knowledge that people like you and others are gaining from these robots, these technologies, can help people that don't understand these things. How do you think that we're going to be able to pass that knowledge down?
And I think like that's one of the biggest problems right now, is that like the people that are working on these, like on most of this stuff, like they wind up having to like write obscure papers that most people don't have access to. And so for Mahesh and I, the reason that we actually did the book was because we wanted a cheap way that everyone could get access to the information without having to like have to pay for like really expensive journals that people don't want to read. And so, like, I think one way is just like getting the information out more. I think the second way things will begin happening more is that now there's just more people working on this stuff. But I think the most important thing is that like you can't, like, if you're not collaborating, you're kind of you're keeping the information to yourself, and that's not really good, right? Because it's not spreading. And the goal is that like it shouldn't just be one person who holds all the information. Like hopefully it should be passed on, and then. So that way, like what I'm working on, or what any of the people who contributed to the book are working on, like, who's to say if it's right or wrong? Like, they can say it's right, but like you could find a way that it's actually wrong, right? But if you can't access that information, like, there's no way you could ever say that. And so I think like most of the people that we work with, all of their stuff is available. It's just a matter of finding it. And so we're trying to make it easier to find right now. But I would say, like, for you guys, if you're interested in things, whether it's this or anything, you need to sort of search it out also, right? So when you go to graduate school, the question is like, well, what do you want to study at graduate school? Like, it's not just like a school is a school. Like, every school has specialties, and you can find a specialty that you're interested in, follow that specialty. And that's another sort of, at least for me, in telling my students, like, you should decide what it is that you want to do, and then find where that's happening and basically pursue it there. And then when you bring it back to another place, basically you're helping it spread then. And so in Philadelphia, there's very little of what I'm doing happening there, but now I'm working with more people, and my students are beginning to go out and do their own things, and I think that begins to help as well. But unfortunately, you have to search. So at least this is one sort of, or what we did is one sort of, one thing that's out there now. Mm-hmm.
Do you foresee a future where this kind of technology replaces things like culture and pushes our society more towards like a globalist kind of world? Or do you foresee a future where these technologies can become incorporated into our culture, or maybe even help advance those ideas in ways that we didn't see before?
I think that this is where I think the sort of ethics of this is really important. And this is why I think everyone needs to have a stance on what's happening, whether you like it or not, right? Because if the people who want the money are the ones that are in charge, and they're the ones developing it right now, you're gonna sort of go to the realm where, you're being listened to. Right now, my phone is listening to me, and I'll probably get a bunch of advertisements on robots or something when I get out of this. It's a serious issue, right? And right now we just sort of gloss it over and we don't care. But you need to, you guys, all of us are the ones who are going to be the ones saying, this is how it should happen. This is how it should not happen, right? And I think the goal should always be to make our we don't want to make things that replace us. That's stupid. But unfortunately, lots of people like doing that. It's like humanoid robots. I don't understand that, because why would you want to make something that looks like a person? You're basically it's not the way to go. But the tools that we make, I feel like they should, where I think it's most evident is in preserving craft. So people using these tools to preserve craft so that they can be that they can be picked up later, they can be reinvented, you could basically look at them in a different light, and hopefully we'll move to that sort of thing, and not the automation where everything sort of takes over, and we're the movie WALL-E. I don't know if you guys know that Pixar movie. We're all just floating around in hover chairs. I don't think anybody really wants that, hopefully. So I don't want the dystopian future, right? I want these things to help us, through collaboration.
How soon in our education do you think we should explore or engage with this robotic?
Well, so again, it's not this is one sort of thing, right? And so I think every tool is not for every person, right? So I mentioned, I can't really draw, so me picking up a pencil is kind of dumb, because I'll just look like an idiot doing it. So it doesn't make sense for me to do that. But for others, it might, if you're really interested in it, you should look into it, understand it, know why you would want to use this versus something else, and then you could pursue it. But again, it's not going to be for every single person. And so I would, at least for me, there are certain things in design you need to understand first, right? So it's not about the tool, it's about what these things can, how they can help you further what you're doing. And so if you start examining these things before you understand what it is that you're trying to do, it could be sort of troublesome. But at the same time, you could be looking at this, you could be looking in parallel to okay, I'm furthering my design, now how could these things begin to modify how I think about problems and solving problems, right? So there, I would say that if you're interested, you should just look into it, how and how soon they'll be integrated into schools. Australia already has over 50% of their architecture schools with industrial robots in them. So that's a pretty big number. But just like CNC mills and laser cutters and 3D printers, everything will eventually meet its end, right? And so you can go out and spend $10 million and build an amazing facility, but in 10 years when it's obsolete, then you have a $10 million paperweight, right? And so the question is, again, knowing the tools, when you would use them, how you could use them. I think in Europe, they do it best because they get the tools loaned to them from companies, and then they can, like, as their research furthers, they can get different tools. So, but yeah, you should look in, like, I would say, as long as you're not like first year, that might mess with your mind a little bit. Huh?
Undergrad.
Undergrad? Oh yeah, no. If you start looking into it like right at the beginning, it might like. Again, parallel. I don't want Mark killing me here.
Perfect, thank you, Andrew.
Is it-
Better talk.
Okay, yeah, sure. Thanks.